Hello everyone, welcome in today's video. And in today's video we want to be fast, because we're going over the highest speed calculation that I have ever done, and should be the highest speed scaling that has been done for a fictional character, at least at this point in time. Because of that, we want to be quick and go straight to what this video covers, in order. First, because I'm making the claim this is going to be the highest speed calculation someone's ever done for a fictional character, I need to outline the competition, so I'll go over a list of other very high speed calculations for other fictional characters. After I do that, I'm going to then do the calculation for that of Jojo's Main in Heaven character from part 5, and go over why it's the fastest speed calculation you will have ever seen. After that, because we can't just have a big number with no context, I will be going over some bonus facts and arrangements we can do with Made in Heaven speed to explain just how fast and how useful such a speed calculation will be for people who are using this character for fictional debating. With that, let's get started. Okay, let's start off small, listing all the fastest speed calculations I could find. I think a good starter calculation that represents them quite well would be this from Imaginary Axis top flash speed calculation, where in the end of the video he results in 23 tredecillion times the speed of light. A nice small number for us to start off with. Now let's go on to the next set of speed calculations, all coming from that of Death Battle. The slower one in Death Battle that I'm going to be mentioning is the dark side calculation at 87 duodecillion times the speed of light, slower than the fast calculation. However, much faster than both of those is the Mega Man calculation at 3 novendecillion times the speed of light, and in several previous videos I claimed this was the fastest calculation on Death Battle. However, I've been proven wrong by my comment section several times. The actual fastest speed calculation on Death Battle is that of SpongeBob, at 8.2 quinvigintillion times the speed of light. Now these numbers are getting very big very quickly, so what I'm going to be doing is converting them all into the format of a number that's smaller than 10 times 10 to the power of how many digits they have. So the dark side calculation becomes 8.7 times 10 to the 40, the flash calculation becomes 2.38 times 10 to the 43, the Mega Man calculation becomes 3 times 10 to the 60, and the SpongeBob calculation becomes 8.2 times 10 to the 78. And to think, at some point later on, even this notation is going to be too small. When I asked in the character stats and profiles Discord what was the highest speed calculation they could find, the highest someone gave me was that of a Sonic EXE story in which it had 1.09 times 10 to the 62 times the speed of light. Which, yes, that does mean in fact that Death Battle's calculation for SpongeBob should be higher than that of anything on character stats and profile, at least if this truly is the fastest calculation on character stats and profile. Faster than the Sonic EXE calculation, but slower than Death Battle on SpongeBob, is in fact the Green Lantern calculation in Webcam Parrot Speed video at 9.41 times 10 to the 72 times the speed of light. So far, Death Battle still have the fastest speed calculation. I'd also asked people in my Discord server if they could find some very high speed calculations for me to talk about in this video. One such member of my Discord server list was able to give a calculation Demon Bane that was 2.16 times 10 to the power of 70 times the speed of light, being almost as fast as Webcam Parrot's Green Lantern calculation. I then found, once again, that Death Battle has an extremely high calculation on the Death Battle wiki for a Gurren Lagann character at 4.6 times 10 to the 117 times the speed of light, which is absolutely insane, but not even close to what members of my Discord server could find. As one member of my Discord server found the Versus Battle Wiki calculation for Lucifer Morningstar at the speed at which he processes information, at 3.71 times 10 to the 201 times the speed of light. Just so you know, that means that is a 3 followed by another 201 digits times the speed of light. And yet that still wasn't the fastest calculation, as once again, List came in clutch and found what was probably the fastest calculation on Versus Battle Wiki for Invisible Dragons, being 2.81 times 10 to the 226 times the speed of light. Currently, we got some decently fast speed calculations, but they aren't nearly fast enough. These are still fast enough that I could write out the full number on screen if I wanted to. If you want to get even close to the number I'm going to use for Made in Heaven later on in this video, we need to look at calculations that are so unbelievably big you cannot write them out on the screen. The first one is from a Jokes Battle Wiki style wiki for that of MatPat the Game Theorist, where they claim that he counted every single thing in a Marioplex, which isn't true, but assuming it is, it gives him speed of 4.10 times 10 to the 12,407 times the speed of light. This means that if I was to try and write this out, I would need over 12,000 digits. This number is so unbelievably large that even a calculator that could handle the Invisible Dragon's calculation, looking like this, is unable to handle the MatPat calculation. The only calculator that I do know that will work is Wolfram Alpha, so that's what I'll be using for the rest of this video. Now this next calculation was one that's actually done for a fictional character with an actual good reason, and that is by Red Eric, and that is for the Amazing World of Gumball, which is a speed calculation applying to every single Gumball character. If you want to go find out what that calculation is, go watch the video, link in the description. A link to all these calculations should be in the description. In which the resulting calculation is 2.33 times 10 to the 41,798 times the speed of light. This is so unbelievably fast. It's not just faster than MatPat, it's faster than MatPat times MatPat times MatPat times every other speed calculation above it. That's how unbelievably fast this is, applying to every single character in the Amazing World of Gumball. A good shout out from someone in my comment section who actually recommended I go over different speed calculations to prove that mine will be the fastest because they noticed this speed calculation. So thank you for letting me know. Or if you want to say how fast a fictional character could be based on context that's actually shown in their canonicity, we can look back to a video made by Imaginary Axis on the Infinity Jaeger. Although the calculations aren't actually his, they belong to two people on Reddit. The Infinity Jaeger himself isn't very fast, being near the top of this list here at 4.1 times 10 to the 42 times the speed of light. The more interesting one is the massive calculation for Superman Prime 10 billion, in which this is theoretically Superman being in the sun for 10 billion years, in which it's said that every 15 minutes gives him about 3 times multiplier, resulting in an insane speed of 5.224 times 10 to the 167 trillion times the speed of light. That's how unbelievably fast he is. This also means if I was to try and write out this number, it would have 167 trillion digits, which means I would never be able to write out this number even if I wanted it to. And yet that still isn't the fastest calculation. But even that is only the second fastest calculation I have found for a different fictional power scale. At least this next one doesn't really apply to a character and more of a theoretical calculation which you could grant a character. The calculation was submitted in my comment section right here, and quite honourably the comment section comment has credited the person it actually belongs to, so you can find out exactly how this calculation works. It does look quite complicated, so I did simplify it into 6 simple steps so you understand how it works. But it's basically in a type 1 multiverse, we look at the Hubble distance between certain universes, and you're going from those different universes and all the space between it within an hour, basically. And with that, we get this massive number that I have to put into Wolfram Alpha once again to try and simplify. In the end, the result I get is 10 to the power of 10 to the power of 162 times the speed of light. So this is the list. This is the highest speed calculations I could find across different places across the internet. Although you may notice the last calculation isn't like the others. It doesn't have a number times 10 to the power of a huge thing. Instead it has 10 to the power of 10 to the power of a huge number. That is because it's using a slightly different formatting because the number isn't actually big enough to represent in the alternative notation. So let's convert all of them so they're all looking like 10 to the power of 10 to the power of some other number and see what that looks like. So now that all the numbers are converted into 10 to the power of 10 to the power of some other number, they really start to be in perspective just how small they are. The second largest calculation, I said that would be impossible to write out all its digits because there's 167 trillion digits, is 10 to the 10 to the 14.22 times the speed of light. So how astronomically big do you think is the last one at 10 to the 10 to the 162.6 times the speed of light? And yet this is nowhere near the speed calculation I'm about to do for Made in Heaven. Now let's talk about how we're going to do this Made in Heaven speed calculation. After all, I've been hyping this up all video to be the fastest speed calculation you have ever seen. And what it is basically on its ability. When Made in Heaven travels forward in time, moving as fast as it possibly can, accelerating time itself, it eventually goes so fast that it actually resets the universe to an identical point in history, essentially going for every single possibility back to that moment. That actually exists in physics. It's called the Poincare recurrence time for our universe. A definition of such will be shown right here on the screen. But instead of that, allow me to explain it through a more mathematical way using that of a video from Numberphile.
Poincare recurrence time. This is something that's arisen from statistical mechanics. Very simply, if we had a pack of cards, and we've only got a finite number of cards in that pack, and let's say we keep dealing each other, hands of 5 cards. Eventually, if we do it for long enough, you're going to get a royal flush, Brady. That's guaranteed to happen. And then if you wait long enough again, you'll get another one, and so on, and so on. And that's true because there's a finite number of cards. Now, what Poincare realised is if you take a gas of particles, you can put a gas in a box. Now, you can put all the particles in one corner of the box, and then they'll disperse, and then they'll move around. But what Poincare recurrence tells us that after a very, 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 very long time, those particles will eventually return to the corner of the box. You always get a repetition. And it's basically because the thing that controls the evolution of that system only has a finite region of what we call phase space, of sort of solution space, that's accessible to it. And so eventually you always come back to it arbitrarily close to where you started. The timescales are truly enormous before you start expecting it to happen. So you can apply this quantum mechanically as well. So when you're doing it in quantum mechanics, what you're really talking about is sort of the evolution of microstates within the quantum system. So, the sort of quantum building blocks of your system. And they will eventually return, they will evolve, but eventually return to their initial state. And what Don Page in this paper has tried to do is he's actually applied that to various types of universe, models of various types of universe.
The only noteworthy difference between the Poincare recurrence time of the universe described in Numberphile's video and the thing that Made in Heaven does is Made in Heaven actually does bring the living organisms from the previous universe into the new one. This is how Imperia got there. But the point of the matter is, the general number of particles and everything of the universe, all the states, Made in Heaven still has to go through all of them to reach this same point in time. So how do we calculate that? Luckily, Numberphile says that as well.
Poincare recurrence time of any system is roughly proportional to the number of sort of states in that system. Because we're applying this to the universe, this is really the number of macro states, the number of these averages of micro states that you can talk about. So let's call this n macro. This then, we would expect it to be about the exponential of the number of microstates. Now, why is that? Well, this doesn't really have to be an E, this could be a 2 or whatever. Basically, any microstate is either in or out of the averaging with some weighting, and so this is the number that you get out. The number of microstates, when you relate to the entropy, is e to the entropy. Let's look at some volume of the universe, okay, of some radius r. Then the entropy, we've done this before, it's the same like as we had before. The entropy that you could possibly have in this region of space, basically, it's proportional to, I'll just be a bit sloppy with factors, r squared over the Planck length squared. So the next step is e to the e to the... So now let's apply it to the really big number that he does, okay? So the question is, what's r? Well, the radius of the universe is about 10 to the 26 meters. Yeah, our visible universe, okay? So as far as we can see, what we call our causal patch. The Planck length is about 10 to the minus 34 meters. So r over L Planck squared is about 10 to the 120, which is a number you often see in physics, actually. This is sort of the number that's associated with cosmological constant problems. But anyway, well, 120 is about 10 to the 2.08. That's where that is coming from. I don't know why he's so precise about this 2.08, because what he's going to do next is, so the number we have is e to the e to the 10 to the 10 to 2.08. But what he does here is he just approximates these e's as tens, which is fine, really, in a broader scheme of things. E, 10. For the sake of cosmology, they're more or less the same thing. All e's become tens, and you get 10 to 10 to 10 to the 2.08, which hopefully is what he's got there, and it is. Okay, so that's where that number comes from. So
one discrepancy between Numberphile's explanation and something that's actually in the paper is the methodology used, as he was describing. It's very similar and does get you the exact same result, but the paper actually uses a black hole style formula, which looks like this compared to Numberphile's holographic formula. This is important for what's going to happen just afterwards. So now if we stop and reflect on it, give Made in Heaven the speed calculation that would be how fast you need to be to go through an entire Poincare recurrence time of the observable universe, we got 10 to the 10 to the 10 to the 10 to the 2.08. Meanwhile, the fastest speed calculation I could previously get on my list of speed calculations was only 10 to the 10 to the 162.6. Now, comparing these two massive numbers may be hard to think. You just think one number is very much bigger than the other. That's true, but how big of a difference is it? Well, what happens if we convert both numbers into a power tower of 3 tens? So the Made in Heaven becomes 10 to the 10 to the 120, okay? And if we look at the calculation that was the fastest speed calculation I could previously find, that becomes 10 to the 10 to the 10 to the 2.21. Not even close. And the fact that these are order of magnitudes apart just shows how ridiculously fast Made in Heaven is. However, this is not good enough. So far in this video, I've only quoted other calculations. I've yet to actually do my own calculation throughout this entire video. So I think it's time for me to make the made in heaven calculation for speed even faster by applying some calculations myself. So how exactly am I going to make my calculation for made in heaven even faster? Well, let's go back to something that was in the paper, because in fact there is not just one time frame for Planck recurrence time, there's in fact two of them. And the second one is for a hyperinflated universe model, much bigger and not realistic at all, but there's two different time frames there. This matters because it means if I can prove the Jojo universe is in fact bigger than the observable one, then I can make the speed of made in heaven for the Poincare recurrence time of the Jojo universe to be even faster. And I'll do this in a traditional style that you guys should have been seeing coming if you've watched some of my previous videos, those being part of the power scaling intelligence series, where I've gone over how a certainly high IQ actually is related to the size of a population that is absolutely gigantic. For example, in my Rick Sanchez video, I outlined exactly what you'd need for that of the universe. Something like even if every single planet in the universe was to have a population like Earth, the total IQ for the smartest person in that universe is slightly below 300. In fact, at the end of my Rick Sanchez video, I calculated if there was a citadel where every single person in the citadel was in fact smart enough to be the smartest of their own universe, Rick being smarter than the entire citadel would only have an IQ of 373. That means in Jojo's Bizarre Adventure, when we are told the ultimate life form has an IQ of 400, that's higher than Rick Sanchez by a considerable margin, and it's even stated to be the final evolution of all species, very much implying that is the max that the universe in Jojo's Bizarre Adventure could achieve. Meaning we can directly use my equation for number of people given an IQ and a population to work out exactly how big the Jojo's universe should be. Now, one thing we should be mindful of before we begin our calculations is what population of the universe the observable universe theoretically in Jojo would have. For example, I have three different calculations for the population of the universe, being based off Drake's minimum population, Drake's maximum universal population, and the full universal population. The full universal population assumes every single planet in the universe has a population like Earth, which I think we can rule out as very unlikely to be for Jojo's Bizarre Adventure. And in fact, because of how grounded Jojo's Bizarre Adventure is in terms of things like extraterrestrial, I would actually use the minimum Drake universal population. So with that, we can bring back the equation then needed to find out the population given an IQ, and we'll plug in an IQ of 400 and see what we get. So let's bring out the whiteboard. Starting off with the Drake million universal population, which was 2.5 nonillion, or an IQ of 273 by comparison. Therefore, an IQ of 400 on this mass exponential scale that IQs have is 27 octovigintillion times larger. Now that number is absolutely gigantic, and you probably got no frame of reference. So imagine this. That population is so large, it's comparable to if every single person in the Drake million galactic population of the universe had a family that just got multiplied by the entire universe's population, and then that new population got multiplied by the universe again. That's how large it is. Or in other words, you could say that compared to the original universal population, an IQ of 400 would imply that the Jojo's universe has a population that is 10.8 octodecillion times larger than normal. We can directly compare that to the mass of the universe, as we will be using the black hole mass equation for that of the Poincare recurrence time. Doing so, we get a mass that's absolutely gigantic, way bigger than that of the original universe. In fact, it's basically a universe squared at 2 times 10 to the 120 kilograms. And this then gives us a final equation time for the Poincare recurrence time of the Jojo universe to be 10 to the 10 to the 10 to the 10 to the 2.3826. So there's our result. Made in heaven is 10 to the 10 to the 10 to the 2.3826 times the speed of light. This is insanely fast and bigger than that of the Poincare recurrence time of our just normal universe, which is 10 to the 10 to the 10 to the 10 to the 2.08. However, it doesn't really look that much bigger, so it makes you wonder, why did I bother calculating it to be bigger? Well, the reason is something that many power scalers use, even accidentally sometimes, called layered scaling. Now, layered scaling is quite basic. It goes a bit like this, and is commonly used by all power scalers. Let's say we have base Goku with infinite speed during Dragon Ball Super. And then we have Super Saiyan Goku, who obviously would also be in the infinite speed category, but the difference between base Goku and Super Saiyan is a 50 times multiplier. We all know this. So we can't just say they're both infinite speed, that doesn't really make sense. And this also is a problem with a lot of cross-verse analysis when we try and say between two infinite speed characters who is faster. So what we commonly do is we correct Goku not just be infinite speed and base, but an infinite speed baseline based on a different feat that would be infinite speed. And then we say as a Super Saiyan, he would be an infinite speed 50 times baseline in a way, so that we know that there is a 50 times difference between the two. They're the same tier of infinite speed, but clearly there is an established multiplier of the 50 times between them. So what does this mean for Made in Heaven? Well, if we go over the stand guide that says that Made in Heaven has actually got infinite speed, likely because of the fact that even though the universe has a finite number of states, there are stands like D4C who can access other universes, thus bringing in an infinite number of states within the finite system. Because of such, we can say that Made in Heaven is an infinite speed character like we just said for Goku. But of course, what would the multiplier be? I mean, it's not going to be 50 times like Super Saiyan, it's going to be something different. We can actually calculate it by using the calculation I'd used for the primary recurrence time of the Jojo universe, 10 to the 10 to the 10 to the 10 to the 2.3826, and divide it by the primary recurrence time of the normal universe, 10 to the 10 to the 10 to the 10 to the 2.08. Now the result you get here is actually quite surprising, as when you divide these two numbers, the end result is 10 to the 10 to the 10 to the 2.3826. That number on top, even though it doesn't look that much bigger, is so exponentially larger than the one underneath, it quite literally rounds to the exact same number. So you could say that Made in Heaven is 10 to the 10 to the 10 to the 10 to the 2.386 times the speed of light. Or you could say that is the number of layers into infinite speed Made in Heaven has. Of course, if you're one of those people who would say Made in Heaven has immeasurable speed, you can also use that many layers for immeasurable speed as well. It follows the exact same argument. Now just some final thoughts that you guys might all be interested in. Yes, this is the fastest speed calculation that is currently on this channel, and I also believe it is the fastest speed calculation someone's ever posted and shared for power scaling. However, that does not mean it's the fastest speed calculation I could do. So if you want me to beat my own record for the fastest speed calculation of all time, comment down below. Now since this number is so large that it's bigger than MatPat's Marioplex, Austin's Minecraftplex, or even bigger than Austin's Minecraft Universal Constant, all of which are numbers so large they get named on the Googology wiki, I have to name this number. And I've decided the name for this number should be the Heaven Recurrence Time, based on Prunkly Recurrence Time and of course Made in Heaven himself. So thank you all for watching this video. A link to all the example speed calculations I'd mentioned earlier in the video should be in the description. If I've missed any, do comment below and I will add them if I can find them again. Also check out in the description of this video my Discord server I'd mentioned earlier, but other people have posted things that help me with this video, as well as check out the list of channels in the description that other power scalers I think are quite nice and you guys might enjoy. Again, thank you all for watching, have a good day.